Greetings, everybody. My name is Godfrey. Today we're going to be looking at finance, growth, and decay in mathematics. This is an awesome topic that as you indulge into this topic, you're going to be enjoying it so much. Come along and enjoy this journey with me. Today we're going to be looking at the overview. When you look at the overview of the entire topic, it consists of the following: simple and compound interest, simple and compound decay, exchange rates, nominal and effective interest rates, loan or savings options. And then the last but not least is to calculate the value of N or R. Now, when we proceed, our focus of the revision will be based only on very important key concepts: simple decay, compound decay, effective interest rates, savings with a timeline, and to calculate the value of R. Now, the very first question is very interesting, whereby our focus point is going to be on being able to start and calculate a compound or a simple interest. So this is wonderful, and we will be building up on this question as we move along. Let us do this. So first of all, here question 1 says, a company bought machinery valued at 15,000. Very important, pay attention to the numbers there, the values. The depreciation is calculated at a rate of 12% per annum. Also important to focus on that, on straight line basis. Then the question goes, it says, calculate the value of the machinery at the end of 6 years. So what has been given to us? The very important information is, first of all, we can see that we need to calculate the value of A, which is actually our final amount. Now, our final amount that we need to calculate. When you pay attention, you'll see that, as I've said, and I've highlighted that and said, pay attention to the values. First of all, we have the value of P, which is being given as 15,000, and I has been given as 12%. 12%. So we write it as 12 divided by 100. You can also write it as 0.12. Very important. And then N, the number of years, is given as 6. Now, very interesting, as you can see what I've done here. I have outlined the given information, and this is what you need to be able to do. You need to sit down and check what has been given to us. A has been given to us, P has been given to us, I has been given to us, but we don't have the value of A, remember? And then N has been given to us. Now, which formula are we going to look at? We're going to be looking at the formula of the simple decay. This is a simple decay formula. And pay attention to the simple decay. It's A is equal to P, 1 minus, very important. Remember, when dealing with compound, normally what do we do? There is a plus sign there, but in this case, there's a minus because of decay. And look at what we do with IN. We multiply I with N because it is a simple interest, simple decay. Right, now with the information that we have, we can move into answering of the question. Now remember, we said we don't have the value of A, the value of P is 15,000, the value of I is equal to 12 over 100, and the value of N is equal to 6. What do we do? With the given equation, we substitute into that equation. So what do we do? In the place of P, what do we put? 15,000, remember? All right. In the place of I, remember here's I, we substitute 12 over 100. Are we together? Right. And then in the place of N there, we must substitute 6. So that we have 15,000, open bracket, 1 minus 12 over 100 multiplied by 6 close bracket. This is what we have. Now we're going to work this out. Interesting, using the calculator, we know we can work this out, right? So this is lovely. So to work this out using the calculator, this is what we're going to do. Our focus is going to be as follows. And as I place this, the given information, there we have it, is the 15,000, open bracket, then we said the 1 minus, yes, 12 over 100, are we together? And we said we multiply this by 6, and then we can simply go and close the bracket and press the equal sign. How much does it give us? 4,200. 4,200 is our answer. Great stuff. Now, so far, what have we done? We have done the simple decay, so we are moving on to calculate the compound decay. Now, what is compound decay? Compound decay is also to do with decaying or decreasing depreciation of the value, but at the same time, now we are using the compound formula that is decreasing. Let us have a look at this. A question 2 has been given to you here, and it states a tractor bought for 120,000. Listen to this word, depreciates. So the word depreciates tells us that we're going to be using decay. Are we together? To 11,090 and 41 cents after 12 years by using the reducing balance method. Calculate the rate of depreciation per annum. The rate of depreciation. So now they say the rate was fixed over 12 years. This simply means that the rate did not increase nor decrease. It remained the same. Are we together? So what have I said to you? I said to you the first thing that we must do is write down the given information. We have been given the following. We have been given A being equal to 11,090 and 41 cents. We've been given P being equal to 120,000, and then, very important, I is the rate of depreciation which we are looking for, and this is what we don't have, right? And then N has been given to us as being 12. What did I say? They spoke about compound. So the word, when you talk about depreciation and we compound decay, like I've said, was our focus. Therefore, you'll see the formula that we use is A is equal to P, 1 minus I. Look at the difference. 1 minus I in brackets to the power of N. Very important. Can you see that? That this is similar to the compound interest, but with the negative sign indicating decay or depreciation. Are we together? Now we can take this information to answer the question. Now what do we do? First of all, what is the value of A? We found the value of A to be equal to 11,090 and 41 cents. Are we together? We substitute. What is the value of P? It is 120,000 rands. Then open bracket, 1 minus I. But we do not have the value of I, right? It is the one that we must find. It is the unknown. And then to the power of N, N being equal to 12. So we can proceed. And when we proceed, you can see now, what do we do? What do we do? First of all, I can quickly show you, first of all, what do we need to do is divide first. To simplify, to divide this side by 120,000, all right, on the right-hand side, and we divide the left-hand side also by 120,000. See, after we have divided by 120,000, what happens? On the right-hand side, 120,000 will cancel 120,000, right? And then you'll be left with open bracket 1 minus I, close bracket to the power of n. And on this side, this is what you're going to have. But this 12, we can get rid of it as well by taking the 12th roots on the right-hand side, and on the left-hand side as well, we can take the 12th root. So that we end up having the following. 1 minus I, can you see? And a 12th root of 11,090,41 and 120,000. That is a 12th root. Remember then we said we are left with 1 minus I. Then we can take I to the left-hand side. We can interchange, right? And then whatever we had on the right-hand side, or from the previous, when we were calculating, will be the 12th root of 11,090,41, divide everything by 120,000. That is what we're going to have. So I becomes positive. Then we also take this over to this side. There's our 1. So what can you see what we end up having? 1 minus the 12th root of 11,090,41, everything divided by 120,000. Now, can we use the calculator to do this? Yes, we can calculate this. We can calculate this, and as we calculate it, let's calculate it. When we calculate this, this is what we're going to be doing. There we have 1, so we type in 1, and you say minus the 12th root. Now, I want you to see what you do on the calculator. You press shift, then you see x to the power of whatever gives you the root sign, right? Then you type in 12, use the arrow sign to the right, then press the bracket button, and now you can say 11,090,41. And then you can either press the sign that shows you must go to the right, or the down arrow or the right arrow, any one of the two. Then you say, type in 120,000. That's what we have. Once you have done that, it looks exactly the same as in the question, and then, or in your calculations, then you press the equal sign. What do I get? 0,17999998. And if you multiply this by 100, what are you going to get? You get 17,9, which is actually 18%. Are we together? And this is what we have, 18%. We have come to the end of the first part. Sit right back there and enjoy the break as we are about to take it. And as we come back, we're going to look at the rest of the topic. Welcome back, guys, from the break. I hope you had a beautiful rest and now you took some coffee and you are back. We are going to look at another section of this topic, and it's very interesting, and that has to do with effective interest rates. Come along and enjoy this. Now, like I've already mentioned, we have already done simple decay, compound decay. Now we are at effective interest rate. Let's have a look at the question. Question 3 says, calculate the effective interest rate if interest is 9.8% per annum, compounded monthly, right? So what do they say? We need to get what? The effective, IEFF. That's effective interest rate. And remember what I said in the previous sections that I've done, that first write down, and that is what we do in financial maths, the information that has been given. Like in this case, we don't have the value for IEFF, but we have I, which is equal to what? The nominal. It's our nominal rate, which is equal to 9.8%. And then we have been given M being equal to 12. Now, what formula are we going to use? We need to use the formula that it is 1 plus I effective, equals to 1 plus I. This is actually I nominal, right? Over M, which is our period. And everything, remember, everything that is in the brackets to the power of M. Now, what are we going to do? We're going to substitute this information into the equation. Let's do that. What do we do? First of all, we do have the value of I, of the nominal I nominal, so that is equal to 0.098. And then the value of M, which is equal to 12, everything to the power of 12, right? So what do we have here? 1, we have open bracket 1 plus our calculation 0.098 divided by 12, close the bracket, all to the power of 12. Very interesting is that 1, we take it over to the right hand side, it was positive on this side, then it becomes -1. Can we use the calculator to calculate this? Let's do that. So in order to do that, there's our calculator. What do we do? Remember, first of all, we must say open bracket. Then we say 1 plus. Then press the bracket sign. Type in 0.098. Down arrow. Divide by 12. Right arrow. And then close the bracket. Then now you must press the exponent button. There it is, to the power of 12. Then the right arrow, and we say -1. You have it. And then we have it, guys. I know you guys are awesome. That gives us equals to 0.1025238919. That we always, because we must convert it to percentage, so we must always multiply that by 100. And then will give us 10, and this is what we are having. Remember, what do we have? We've calculated 0.10252, and then we multiplied it by 100, and then the calculator gave to us that it is 10.25%. So we have found the effective interest rate. What is the next step? It is to look at savings with a timeline. So also in financial maths, you need to be able to do what? To calculate savings. And we said, first savings, we can calculate savings or loans. Let us indulge into this. When you look at question 4, it says, a savings account was opened with an initial deposit of 24,000. Interesting. 18 months later, 7,000 was withdrawn from the account. And it says, the question says, calculate how much money will be in the savings account at the end of 4 years if the interest rate was 10.5% per annum. Interesting. Compounded monthly. We're going to look at this now. Why? How do we work with when it's not compounded annually but monthly? Now, guys, very important. You need to draw a timeline so that you have a proper understanding of what is happening in this question. We have been given N being equal to 4 years, right? But the question talks about compounded monthly. Therefore, we need to convert this to months. How do you do that? You say, therefore, you multiply it by 12, and that will give you 48 months. Are we together? So we're talking 48 months. Now, when you break up this 48 months, we start first at P1. That is where we start. It has been given to us as P1 is our initial amount of 24,000, right? And they say after 18 months, interesting, after 18 months, what happened after 18 months? We are now going to get our final amount 1, which will be A1, right? Then from what is left, 7,000 was deducted, right, after here at this point. And the money that was left, which is our A1, will then become our, then we have our P2, then we have our P2. When we started P2, we'll move for 30 months. How do we know it's 30 months? Because if you take the 48 there, 48, and we know we subtract 18 months, that will give you 30 months that is left. Because we're doing our calculations in months. Now we can proceed and write down what we have. Do we have A after 18 months? No, we don't have. Do we have P, initial amount, P1? Yes, it's been given, like I've said, 24,000. We have been given I as 10.5% per annum. And then N is equal to 18. Compounded monthly. Right. Now, let us do our calculations. And I want you to pay attention, very important. What you can do, first of all, is into the formula that we are using, which is the compound formula, is this one. P will be equal to 24,000, right? Then we have open bracket, 1 is still there, plus I, interesting. I, we know it is 10.5, therefore it can be written as 0.105. Remember, we said 10.5% can be written as 10.5 over 100, which can also be written as 0.105 as a decimal number. Interesting is because it's compounded monthly. How many months are there in a year? 12, right? Then we divide that by 12. And then we close the bracket, everything to the power of n, which is 18. All right. Now we can use our calculator to work this out. And therefore, what are we going to do? First, you will type your 24,000, open bracket, type 1, plus, then you press the button of the fraction, you type 0.105, divide everything by 12, right? So I took either the right arrow or the down arrow. Here I can press the right arrow. Make sure you close the bracket and then press the exponent button to the power of 18. Once we have that, we press the equal sign. Can you see that gives you 28,074,70. So we can proceed. So once we proceeded, remember what we said. Now we have found the following. We have found P, we know P1 is equal to 24,000. We found A there, right, after 18 months, which is equal to 28,074,70. Now there was a withdrawal that was made for 7,000. What does withdrawal mean? It means we must subtract the 7,000 from the 28,074,70 cents. And when you do that, it will give you 21,074,70. So what are we going to do with this amount? What are we going to do? Remember, we now have our new P2. This P2 will now be equal to 21,074,70. So now we want to know, after the 18 months and the 30 months that is left at A2, which is the last final amount, how much will be in the savings account? Are we together? So we proceed. In order to do that, A2, we don't know what the value of A2 is, right? Do we know the value of P2? Yes, we've calculated that, and that is 21,074,70. Do we know the value of I? Yes, it's 10.5 per annum. Compounded monthly. Remember, this one is 0,105 divided by 12. This is what we are having, right? Remember, this is how we calculated that, right? And then N, yes, is the 48 minus the 18, which is 30 months. Now we can proceed and do the calculation. Doing the calculation, because it's a compound interest, so we're still using the compound interest formula. So it's A2 is equal to P. What is the value of P? 21,074.70 cents. And then open bracket, 1 plus, what is the value of I? Remember, now we know now. It is 0,105 divided by 12. What is left? Everything to the power of 30. Are we together? Let's use the calculator to work this out. So to work this out using the calculator, we're going to take, we said, and we can move this around and say 21,074.70 cents, right? Then we open the bracket. After opening the bracket, we say 1 plus the fraction button, 0,105. We can right arrow button, and then 12, right arrow button, close the bracket. And then we say everything to the power of 30. Are we together? Then now we can press the equal sign and look at that. Isn't that the answer? That gives us 27,369.56. So what have we done? We have calculated the amount that was left after 7,000 have been withdrawn after 18 months. So, boys and girls, this is wonderful. This is awesome. And I hope that you are benefiting from this exercise. I hope that you are enjoying this exercise, because so far we have seen great things. Sit right there or stretch a little bit. After the break, we're going to look at more finance questions. Welcome back, everybody. I hope you had a wonderful break. So we're going to go further into the next part of the section, which talks about the finance part, which talks about calculating the value of R. Let us come together and indulge into this question. So question 5 has been given as, it says, a car costing 198,000 has a book value of 102,745.34 after 3 years. The value of the car depreciates at R% per annum. And this is what we are going to be looking at on a reducing balance. Compounded semi-annually, interesting. Then the question says, calculate R. So let us talk about what are the compounding intervals. Compounding intervals are very interesting, and when you look at them, first of all, we have annually. What do we talk about? Annually, when you're compounding annually, we say once every year. When you are compounding semi-annually, it means twice every year, right? If you compound quarterly, how many quarters are there in a year? Absolutely 4. So that is 4 times every year. And then monthly, how many months are there in a year? 12. That means 12 times every year. So these are your compounding intervals, and you need to be familiar with them. Now we can proceed and look at the given information. Remember, we had been given A as being equal to 102,755,34. And remember what I said, this whole information here is step number 1. You need to write down this information, write it down first before attempting the question. So what do we have? T is equal to 198,000. N is equal to 6, compounded semi-annually for 3 years. Now you would ask me, but where does the 6 come from? Because the question spoke about 3 years. Very important. Every time when you work with the number of years, compounding intervals, using compounding intervals, in this case they talk about semi-annually. This means we're going to take the 3 years and multiply it by 2, because semi-annually means it's compounded twice. So when you multiply by 2, that is why we get 6. And then R, we don't know what R is percent per annum. What are we using to calculate this? We are using the depreciation or decay compound formula, right? So we say A is equal to P, 1 minus I, in brackets, everything to the power of N. Now we can substitute into this formula. Let us do the substitution. So when we substitute, do we have the value for A? Yes, we have the value for A, which is equal to 102,755,34. Do we have the value for P? Yes, which is 198,000. Then we open the bracket, 1 minus, what is the value for I? We don't know I, we know that it is R over 100. Remember that I, and what we did also in the previous sections, we said I must be divided by 100, or you can write it as a decimal, right? And then we close the brackets, everything to the power of N, which is 6. Now we can proceed. What do we do first? First of all, we need to simplify the question by firstly dividing both sides by 198,000. So if I divide by 198,000 on the right hand side, I must do the same on the left hand side. And then 198,000 will cancel with 198,000. So you're going to be left with 1 minus R over 100 in brackets to the power of 6, right? We need to get rid of that 6. So now we can take the 6th root of that on the left hand side, and then the 6th root, on the right hand side and on the side on the left hand side. So what do we have? This is what we have here that we have calculated. Then on the right hand side you'll be left with 1 minus R over 100, right? Okay, so when we look at this question, as we have already indicated, now we're going to do what? Substitute. We've substituted, now we must work this out. In order for you to be able to work this out, is that we need to calculate this part. So calculating that part so that we get there. How do we do that? We use the calculator in order for us to be able to do just that. And using the calculator, we're going to calculate. You're going to press shift, then you press the root sign, root together, then type in 6, right arrow, then the fraction button, 102, you type 102,755,34, down arrow, or even the right arrow, 198,123, zeros, and then you can press the equal sign. This is going to give you 0.896,440,762. Now, very important, is now to be able to do the following. And to be able to say, okay, now that I've calculated that part, I'm going to take over the 1 to the right-hand side. It was positive on this side, so if I take it to the right, it's going to be minus 1. Are we together? So you say minus 1, so that we get the answer of negative 0.103,559 238. And then we will multiply the left-hand side by a negative 100. What you do on the left, you do on the right, multiply by negative 100 on the right-hand side, so that negative 100 will cancel with a negative 100, so that you are left with R. And when you calculate this part, you end up getting 10.36%. Let us use the calculator to work this out. So to work this out, there we go. We have 0.896,444,0762 minus 1. That gives us how much? Negative 103,555,9238. Then I said we must multiply it by negative 100, and that will give you 10.35559,238. And when you round this off to two decimal places, you end up having 10.36, and this is what we're having there. So, wonderful stuff, boys and girls. We have reached the end of the lesson, but before we complete the lesson, we're going to be talking about summary. What have we done? What have we looked at, and what have we gained? Let's do that. In our summary, we realized that what have we done? Simple decay, where we say A is equal to P, open bracket 1 minus IN, close the bracket. So we did that. We also did compound decay, where we said A is equal to P, open bracket, 1 minus I, close the bracket, everything to the power of N. Then we did the effective interest rates, where we spoke about 1 plus I effective equals to, open the bracket, 1 plus I nominal, divide by the period, close bracket to the power of M, which is also the period. That's what we did on effective interest rate, and then we also did savings with a timeline, and where we calculated, remember, 18 months, and after 18 months we're left with 30 months, and we calculated that. We also went over to calculate the value of R, given all the other information. So we have come to the end of today's lesson. Thank you very much for sitting tight and enjoying this lesson. I hope you've gained a lot, and all the best for the future to come. My name is Godfrey, and I'm out.